So I wanted to go ahead and get in your hands since you have a 3-day weekend in case it would be better for you to start studying over the weekend versus putting it off until next Tuesday, because next Tuesday is when we'll review and the next Wednesday is when you're testing. Okay. I also want to warn you about next Tuesday. We will have a visitor in our room, one at least, maybe more, during that lesson. It's a review day, but to spare you all the long, boring details, basically there's a lady that's coming to watch me implement a task that is our new math kind of initiative. So normally on our review day, we would do the vocab test and then we would play a review game. We will still do that, but we're going to have a little task that we're going to do in between those two. So you're going to do the review on Tuesday, and then there'll be a worksheet for you to go sit down and work on. We're going to do it first individually, so you won't be working with a partner. You'll be all by yourself. And then I'll be coming around to see how you're doing. Then you'll group up. You'll pair up with someone, compare answers, talk it out, make some changes, formulate what you think you should have, and then we'll do some presentation of letting us share out what you guys got and what the correct answer should have been. It will all be related to this chapter and the review for the test, so it's not wasted time. It's just extra that I have to do because they're coming in to observe that, okay? And then we'll move on with our review game. Test will be Wednesday. Okay, so we left off with this proof, but we didn't finish it, and because you will see proofs similar to this on your test, I wanted to make sure that we went back and really understood this question, okay? So before we left off, we had some stuff written down, and I was trying to hurry through it, and I didn't feel good about it, so I want to make sure we go back and really understand. So we started by saving some time here, and I just circled all of this and pointed to step number 1 would be given. And basically what it told us in the given was that both of those shapes are parallelograms, right? And then they wanted us to prove that angle H was congruent to angle M. That's our goal. We don't know that yet. What we started talking about was we did know that in a parallelogram, opposite angles were congruent, right? And we said that G would be congruent to this angle HJN, and that L would also be congruent to this angle KJM. And the reason I can say that they're going to all end up being congruent was because these two were vertical, and so we could say they're congruent by vertical angle theorem. Okay, so we had, remind me what we had listed down so I can name things correctly. So what did we have for number 2? Okay, what do we have for the statement though? Angle H, JN, and then what else? Okay, and that was by, in a parallelogram, opposite angles, I'm going to just do this really fast because you already have it, are congruent, okay? And then we said vertical angle theorem next, okay? Don't forget that's vertical. And that was that angle HJN was congruent to angle MJK, correct? Okay. And then did we have anything after that? Okay. So we used transitive property to say what? Okay. And make sure everybody understood that, because that was the part I think we left off was right there. Oh, we do? Okay. So before we get to that, did everybody really understand where this came from? That if L is congruent to MJK and MJK is congruent to HJN, that L is congruent to HJN? Everybody's there? Okay. And so then that gave us that this angle L was congruent to this angle HJN here. And then what did we have next? Okay. So then we did another transitive property, or did we? Yeah. So angle L was congruent to angle G. And that was another, I'm just going to put ditto marks for transitive property of congruence. Okay, and that again, make sure you understand where that came from. We had angle L was congruent to HJN, and we had HJN was congruent to angle G. So again, by transitive, that gave us L congruent to G, right? All right, and so then that meant that this angle was congruent to this angle. And then where were we going to go from there? Does anybody remember? Wasn't sides. We were still talking about angles. And our goal is to get that angle H is congruent to angle M. Does anybody remember the theorem we talked about trying to use eventually? Something to do with supplementary angles. Molly? Okay, so what we talked about saying was that in a parallelogram, consecutive angles are supplementary, right? So we should be able to say that H and G are supplementary and L and M are supplementary. And then remember there was a theorem that said if two angles are supplementary to two congruent angles, then those two angles have to be congruent. What was congruent supplements theorem? So number 6, we could say angle H and angle G are supplementary. And at the same time, we could say the other pair of consecutive angles involving L and M. So angle L and angle M are supplementary. And how did we know they were supplementary? Not yet, that's coming later. In a parallelogram, good, consecutive angles are supplementary. Remember, there are 5 properties of a parallelogram that you have to have memorized. And one of them is that consecutive angles are supplementary. So now, again, I want to point out that congruent supplements theorem so you understand where that's coming from. H and M, which are what we're trying to prove congruent, are supplementary to angles G and L. And we just said in number 5 that G and L are congruent. So if G and L have the same measure, and M supplementary to L and H is supplementary to G, the only way that's possible is if H and M are also congruent, right? Okay, so that's the congruent supplements theorem. So number 7, angle H is congruent to angle M, and that is our congruent supplements theorem. Now there are other ways you could have worked this proof. That's probably the fastest way we could have come up to work it. The longer way would have been involving the definition of supplementary and actually finding the measures of the angles and going a lot further into that. But I don't think, if you can remember that congruent supplements theorem, that will save you a lot of time. Okay? Any questions about 6.2? Okay, let's move on to 6.3 and 6.4. So 6.3 and 6.4, again, more quadrilaterals and more properties. So we're going to start with 6.3 is actually going to be the opposite of 6.2. 6.2 says if it's a parallelogram, here's all these properties. So it's like the converse. 6.3 is going to say, here's the shape. Is it a parallelogram? And you're going to have to decide if it's a parallelogram. So we're going to talk about all the ways to prove it's a parallelogram, which is just going to reinforce what we learned in 6.2. Okay? So it's almost the same exact lesson. We're just going backwards. We're not going to call them converses, though, even though it's like the idea of the converse. So conditions for proving that you have a parallelogram. On your property sheet, what I would do is I would make a column that says ways to prove it's a parallelogram. We already have 5 properties, but now we want to say, how can I prove that I have a parallelogram? And we will do this for most of our shapes. We'll learn properties about them, and then we'll look to see what are the ways we can actually say we have that shape if we don't know that that's what it is. So most of these are going to be the exact same as the 5 we've already learned, but a couple of them are a little bit different, and then there's one extra way that you can prove it's a parallelogram. So I'm going to start with things that we learned last time that are identical. So I'm going to skip down to this one first. It says if both pairs of opposite sides of a quadrilateral are congruent. So if you have a picture of a 4-sided shape and both pairs of opposite sides are congruent, it is a parallelogram. So the first way I can prove it's a parallelogram is if both pairs of opposite sides are congruent. If both pairs of opposite sides are congruent, it is a parallelogram. Key in on that word both. One pair being congruent is not enough. You must have both. Second way that we learned last time, that is identical this time, is if both pairs of opposite angles are congruent, then it's a parallelogram. So another way is if both pairs of opposite angles are congruent. I'm going to come back to that first one in a minute. I'm going to skip to this next one. The third way that I'm going to write down is, again, if the diagonals of a quadrilateral bisect each other. And it is plural, so I'm going to say both. You do have to have both. So if both pairs of diagonals bisect each other, or I'm just going to put both diagonals bisect each other. So you can't just have one diagonal bisected, both of them have to be bisected, and if so, that proves it's a parallelogram. The fourth way is not listed there on any of those charts, and it is also from last time, and that's our definition. Remember, we learned that definitions are always biconditional. They go both directions. So if it's a parallelogram, what did the definition say? Opposite sides are parallel. So we could say then if both pairs of opposite sides are parallel, must be a parallelogram. So this comes from the definition. So I'm going to put that there, definition. And it would be that both pairs of opposite sides are parallel. Again, it has to be both pairs. You can't just have one pair of parallel sides. That will not prove it's a parallelogram. Okay, there are two other ways you can prove it's a parallelogram. One of them is similar to what we learned last time, but it's a shortcut, so it's a little simpler. Last time we learned if it's a parallelogram that every pair of consecutive angles will be supplementary, right? But you don't have to have every pair supplementary. If you have one angle and it is supplementary to both of its consecutive angles, so basically that's like two pairs including the same angle each time. If you look at these two angles, what's 180 minus x plus x? 180. And what is 180 minus x plus x? 180. So this angle x is supplementary to both of its consecutive angles. Do you see that? So you don't have to know all four angles. All you need to know is three angle measures, and as long as the one in the middle is supplementary to both of its consecutive angles, that's enough to say it's a parallelogram. Okay? So we're going to write down that if one angle is supplementary to both of its consecutive angles, that's enough to say it's a parallelogram. And the reason for that mathematically is because, let's say, for example, this is 130 degrees, and this is 50 degrees, and this is 50 degrees. Oops, 50 degrees. Would you agree these are supplementary? These are supplementary. So if this is 130 and 50, that's 180, plus 50, that's 230 degrees. What do we know that all four angles in any quadrilateral has to add to equal? 360. So what does the other angle have to be? 130. Oops. And so therefore, we will end up with all pairs of consecutive angles being supplementary. But we don't need that fourth one because of that 360-degree rule. As soon as we know these three end up working, then the fourth one will have to end up working, okay? All right, last way is the one I skipped, and this one is a shortcut as well. It's not a new property, it's just a shortcut on how to prove it's a parallelogram. And so this is the last way, number 6. There's going to be 6 ways to prove it's a parallelogram. Same 5 properties, it's just that this 5th way is a little bit shorter, and then this is just a shortcut combining 2 properties. So this says if one pair of opposite sides are both parallel and congruent. One pair are both parallel and congruent. That's enough to say it's a parallelogram. So if you just have just opposite sides parallel, just opposite sides congruent, you have to have both pairs. If you just have opposite sides parallel, you have to have both pairs. But if you have parallel and congruent, you only need one pair, but it has to be the same pair. Okay? That's the tricky part. So if one pair of opposite sides are both parallel and congruent, that's enough to say it's a parallelogram. Where they'll trick you, they'll draw something like this. Is that enough to prove it's a parallelogram? No, you have one pair of sides parallel, the other pair is congruent. You don't have both parallel, you don't have both congruent, and you have one pair of each, but it's not the same pair. Okay, so it has to be the same pair. That's why in this picture you'll see parallel and congruent on the same pair. Everybody clear? You only need one of these to prove it's a parallelogram. You don't need all 6, so you only need one. As soon as you have one of these properties, you can say it's a parallelogram. So in this section, there's going to be a lot of problems where they're just trying to get you to decide, is there enough information to prove it's a parallelogram, or show that it's a parallelogram, or prove that it's a parallelogram. So some of them will be quick and easy, some will be a lot more work. So this one says, show that this is a parallelogram for A equals 3 and B equals 9. For this one, I'm going to make it easier on us. Instead of making us write it out as a whole proof, we're just going to show our work neatly and then tell what that tells us in terms of properties. So if I want to show this as a parallelogram, what am I going to have to do? Okay, plug in A and plug in B, right? And find the measures. Do I know that they're equal, though? No. So you would be looking at it kind of indirectly saying, if they're equal, do I come out to get A equals 3? Or if they're equal, does it work out to be B equals 9? Which isn't necessarily wrong, but you're starting with an assumption instead of what's been given. So it's probably better to start with what's given and then see what do I get from that. Does that make sense? Okay. All right, so when I say you don't have to write a proof, you do still have to show your work and label everything. So we can start with pick a side. KJ. Do not put a line segment above it. KJ is 15A minus 11. Plug in A. And what do you get for KJ? Okay, 34. Then pick another side. So now we know KJ is equal to 34. What would be another side that would be helpful for us? LM. So LM is equal to 10A plus 4. Plug in your A. And what do we get for LM? Careful. You plugged B in instead of A. 34. So we show our work to see that KJ is 34 and LM is 34. So then what does that tell us about KJ and LM? They're congruent. So I want you to state what you now know based on that information. KJ is congruent to LM. Then what are we going to have to do from there? Okay, do the other two sides. So let's start with KL. 5B plus 6. This time we're plugging in 9 for B. And what do we end up with for KL? 51. And then we'll go and do the same thing to the opposite side, JM. So we have 8B minus 21. Plug in 9. And what do we end up with for JM? Okay, 72 minus 21 is 51. And then what does that tell us about KL and JM? They're congruent. Make sure you are putting line segments above them when you're using that congruent symbol, that chapter 1 correct notation. Now, how does that show this is a parallelogram? Okay, so then I want you to state what property did you use to prove it was a parallelogram. So then at the end you could say both pairs of opposite sides are parallel, or you could have shortened that down to, where did that come from? What is both pairs of opposite sides being parallel coming from? The definition of a parallelogram. So you could have just put definition of parallelogram because that is how we knew. Nope, just the one that's the definition. The definition was it is a four-sided shape that has opposite sides parallel. Oh, it's not parallel. So sorry. It is not parallel. It is congruent. So sorry. Yeah. I mean, I don't know why you were confused. So sorry. Make sure that you are with, not me, with yourself, with what you knew. Yes, Tyler, you can't use that because it's not the definition. If it had been opposite sides parallel, you could have used definition. But for all the rest of them, you have to write it out. Okay, I'm so sorry. Everybody understand where I messed up? We're good? Cindy, good? Okay. So sorry, guys. My mistake. Man, it stinks. If only I could be perfect. But I'm not. I don't know what you're talking about.
Miss Anna, she tells stories, then she forgets she tells us stories, so she tells us again.
I got you.
And then there's time in class, and it's like,
So you keep wasting time? I got you. I keep hitting the button too many times. So this one is going to be identical to the one we just talked about. So I'm not going to take the time to really show everything here. Okay, let's just talk about what we would do here. So if we want to show that this is a parallelogram, we would do the exact same thing. We would plug in 10 and 6.5 in for these angles, right? Okay, so we would get a measure for angle Q, we would get a measure for angle R, and we would get a measure for angle S. And to save time, I'm just going to tell you what those measures are so that we don't have to go through and work it all out, okay? So Q and S are going to be 46. You would need to do that, though. Show your work. And then that makes angle R, not right now, just on the homework, you would need to do that, okay? 134. Okay, so on the homework, you would write down Q and what its expression is. You would plug in the Y value. You would show your work, get your answer, just like we did on the last one. Are we good with that? Okay, so now you have to figure out how you're going to prove this. Which of these properties could we use? Okay, Molly says 5. One angle is supplementary to both of its consecutive angles. But then I also heard opposite, both pairs of opposite angles are congruent. Be careful. Do you know the other angle P? Okay, how would we solve for it? Okay, you can't say that consecutive angles are supplementary because you don't know it's a parallelogram yet. What you do know is that for every quadrilateral, all 4 angles add to be 360. So you could take 46 plus 46 plus 134, add them all together. What would we get? 220. And if we take nope, 226, yep. And if we take 360 and subtract 226, what do we get? 134. You would have to show that work. You cannot say opposite angles are congruent because you don't know angle P. And you can't say that it's supplementary to Q because you don't know it's a parallelogram. I'm going to say that several times because that is the mistake I often see on the test. Be careful. You would have to show using the property of any quadrilateral to find angle P, and then once you know angle P is 134, then you could say that angle Q is congruent to angle S and angle R is congruent to angle P, and both pairs of opposite angles are congruent. Okay? But you would have to show this, and then you would have to say angle Q is congruent to angle S, and angle R is now congruent to angle P, which means both pairs of opposite angles are congruent. This is what I would expect to see if you're going to use that method. If you want to do what Molly said and just say that we have one angle supplementary to both of its consecutive angles, then you would say the measure of angle Q plus the measure of angle R is equal to 180. And the measure of angle R plus the measure of angle S is equal to 180. So one angle is supplementary to both of its consecutive angles. So you can choose which way you want to write your answer, but if you choose to do it the both pairs of opposite angles congruent, you must show work using quadrilaterals. Otherwise here, show me that they add to be 180 and then state the property. Any questions? Okay, so not a full-fledged two-column proof, but, oops, I went to the wrong one, excuse me. You do not have to do a two-column proof. You just have to show the work, labeling it correctly, and back it up with a property. Okay? All right, now these are a little easier. It says determine if the quadrilateral must be a parallelogram. So based off what we're given here, would we say yes, this is a parallelogram, or no, it is not? Yes, and it says justify, so which property would it be? 5. One angle is supplementary to both of its consecutive angles. So we would say yes, one angle is supplementary to both of its consecutive angles. Look at the next one that you have on your notes. Is that enough information to say it's a parallelogram? Everyone says no? My goodness. It's annoying. I'm sorry. Where's my little mouse? Okay. So you guys all say no? Correct. We just have one pair of opposite angles congruent. So when it says justify your answer, you would need to say something like, be more specific than not enough information. Okay? We need another pair of opposite angles congruent, or there's only one pair. We need two pairs of opposite angles congruent. But be specific about why it's not enough information. Okay? So don't just put not enough info. So no, we need both pairs of opposite angles congruent. Okay, and then if you look at the next little slide in your notes, it's just going to remind you that you only need one of those things to show that it is a parallelogram and that the definition also works. And now we're ready to look at a graphing problem, okay? Show that the quadrilateral ABCD is a parallelogram by using theorem 631. Okay, so first of all, I would never do this on a test. Okay? I would never say by using theorem 631. That is just because it's in this book, chapter 6, section 3, the first theorem. So we won't do that. But for the homework, you might have to look back at your notes to see what was 631 if they do that in the book, okay? So when you look back, it is one pair of opposite sides are both parallel and congruent. Here's what I want to tell you. You can be guaranteed on your test next Wednesday, you will have a question that you have to graph like this. It is not going to say, show this is a parallelogram. It is going to say, and you may want to write this down, for the test, what kind of quadrilateral is this? And you are going to have to use your properties of all the 7 types of quadrilaterals we'll have learned by then. You're going to have to use all your properties to decide what do I think it is and why is it not the other ones. And you're going to have to justify and explain and show work. You won't be allowed to just graph it and go, oh, looks like a rectangle, it's a rectangle. You'll get 0 credit for that. You will have to back it up with properties and back up that with work that proves the property's true, okay? So right now, everybody needs a sheet of graph paper, grab one. And if you don't have extra in your binder, grab some for your binder. Go ahead and graph this shape on your graph paper. And normally I would do this on graph paper too with you, but since we've got a couple people missing today, I'm going to make sure that they can see everything we do here on the board. Javi and Katrina. Obviously, Alexis misses you since he didn't even notice you were gone, Javi and Katrina. Okay, so we're all just graphing this shape, right? So obviously, once you get it graphed, you're going to try to decide what you think it looks like, right? And again, by the end of this chapter, you will have quadrilateral, which means it could just be a quadrilateral. It may not be anything special. Or it could be that it's a parallelogram. After today, you're going to learn about special parallelograms called the rectangle, the rhombus, and the square. And then you will learn next class period on Monday about the trapezoid, the kite, and the isosceles trapezoid. So there'll be 8 things that you could have possibly listed as an answer when it comes to this question on the test. It's just a quadrilateral, or it's one of these other 7 special ones that we're talking about. But you can't just look at it and go, yep, that's what it is. You have to back it up. So if you think this is a parallelogram, which obviously since it says show it is a parallelogram, we know it is a parallelogram. It just won't say that on the test. So we have 6 ways we could prove it, okay? And we're going to decide which of these 6 ways can we do using graphs. So let's start with opposite sides congruent. Could we show both pairs of opposite sides are congruent using graphs? How? What would we need to find? Distance. So you may want to make a note on here. You would have to use distance formula. If you like distance formula, then you could just do distance formula 4 times to show that both pairs of opposite sides have the same distance. Okay? Number 2, do we have a way on graph paper to show that both pairs of opposite angles are congruent? No, we wouldn't have any way to know what those angles are, and we're not going to break out a protractor and measure. So number 2, we would not do as a way on graph paper, okay? Could we show that both diagonals bisect each other? Okay, there's actually an easy way to show that. If they're bisecting each other, where would they have to cross? At the midpoint. And that means that both lines would have to have the same midpoint, right? If their diagonals are bisecting each other, think about that with me. I'm going to redraw this over here so I can erase it. If both diagonals are bisecting each other, do you guys agree that that would mean this would have to be the same midpoint? Okay, so we could basically find the midpoint of each diagonal, and if they have the same midpoint, then they're bisecting each other. So that would probably be a pretty easy way to do it, and this would be using midpoint formula. I'm going to make sure everybody understood that, though. Yes, ma'am.
So, like, to find it, like they said, triangle is the same type of triangle.
Mm-hmm.
Like, add up all the x's and add up the y's.
No, that's just related to triangles, not to our quadrilaterals. Good question. Okay. Could we do both pairs of opposite sides are parallel on a graph? Yes, what makes lines parallel? Okay, same slope. So if we just wanted to use slope, we could do just slope and then show that all opposite sides have the same slope. So you do slope 4 times. The way they're telling us to work it on this problem is to show, nope, that's number 6, never mind. Can we do one angle is supplementary to both of its consecutive angles on a graph? No, because we don't know what the angles are. So we can't do number 5 on a graph. 6, this is the way they're telling us to do it, is one pair of opposite sides are both parallel, which means we're going to have to find what? Slope. And congruent, so they want you to do distance formula. And but are we doing it 4 times? Just 2. Twice on the same pair of lines, okay? And they're just making you practice both of those formulas, so it's probably good review. Okay, so when it gets to the test, though, you're going to get to choose which method do you want to prove that it's a parallelogram. If it's a parallelogram, you're going to learn here in a little bit, it could be something more than just a parallelogram. And then you'll look at what else could it be. Okay, that's right. But the first thing will be to prove that it is a parallelogram or that it is not a parallelogram. It may not be a parallelogram on the test, and it may just be a quadrilateral, or you'll learn on Monday that that means it could be a kite or a trapezoid. And so then you'll rule in those or rule them out. No, you will have to know all your properties. Sorry. Okay, so here we go. Quickly, let's decide which pair of sides do you want to use since they said we had to do it by 631.
A, B, and DC.
Okay, A, B, and DC. So show your work. You won't get credit unless you show and label. Don't just have numbers on your paper. If I don't know what they're for, I'm not going to give you credit. So we need to find the slope of AB. And since we graphed it, you can just count rise over run, or you can use your slope formula. So for A to B is not 1/4, because that would be a positive slope. Okay, so does everybody else agree that we're going down 1 right 4? My graph's not very good here, so double check it on your graph paper. Is that correct? Okay. Then let's do the slope of DC. What's the slope of DC? Okay, -1/4. And then just like on the last ones we did where you show, what does this tell us?
That they're parallel.
They're parallel. So then right, AB is parallel to DC. So show your work, label it, then tell me what does that tell you. Moving on, we have one pair parallel. We want that same pair to be what? Congruent. So now what do we need to find? Distance. Distance from A to B. Do not put a line segment above it. It is the square root of, remember your formula is x2 minus x1 squared plus y2 minus y1 squared. So we're going back to using these coordinates for A and B right here and plugging them in. So we're going to have the square root of what? 6 minus 2 squared plus 2 minus 3 squared. That's going to give us the square root of 4 squared plus -1 squared, which is the square root of 16 plus 1, which is the square root of 17. So then we're going to do the same thing for DC, showing our work using our distance formula. I'm not going to write the formula again since I already have it on the board. Let's go on to the points D and C. What would I have here in my first set of parentheses?
1 minus 5.
Okay, 1 minus 5 squared plus 1 minus 0 squared. That gives us the square root of negative 4 squared plus 1 squared, which is the square root of 16 plus 1, which is the square root of 17. Make sure that when you're showing this, you're keeping your square root over everything as you go, that your work is correct all the way down. And then what does that tell us about A, B, and D, C? They're congruent. So make sure you put your line over them, correct notation. And it said show that it's a parallelogram using that theorem. We showed that they're parallel. We showed they're congruent. I'm going to go ahead and state that theorem because on the test, you're going to have to state the property. It's not going to say by this property, right? So we have one pair of opposite sides parallel and congruent. So again, when you get to the test, you're going to graph it. You're going to decide, do I think it looks like a parallelogram? If you do, you're going to prove it's a parallelogram one of these 4 ways, since it's on graph paper. And then you're going to list the property that you proved. And then after today, you'll realize you've got to go a step further to rule in or rule out other shapes, okay? Any questions on 6-3? Taught it too many times. Say it again. You would have all of that plus more come test day. But for today, on your homework, that's all you would have to have because you're just showing that it's a parallelogram. No, they'll just be one. So it won't. It may take you a little bit for this one question, but it won't be the whole test is full of things like that. Okay, if you look at your notes, you'll see there's a chart next, right? And it lists all of them for you. So it's giving you everything we wrote on the board. It's just exactly what's on the board. And then again, I want to emphasize that to prove it's a parallelogram, you only need one of those 6 ways, okay? One. You don't have to have all 6. All right, 6-4. Maybe. We'll see. I think so. Okay, so on 6-4, now we're going to look at 3 special parallelograms. So we're back to that property sheet. We're going to talk about the properties of a rectangle, a rhombus, and a square. So first of all, I'm going to change the definition on every single one of these. Make sure in the notes you change it. A second type of special quadrilateral is a rectangle. A rectangle is a parallelogram. I want you to change that to parallelogram. We're going to include that in the definition. So a rectangle is a parallelogram, and then more specifically, it has 4 right angles. So on your property sheet, make sure you write down rectangle. First property is it is a parallelogram, which means if it's a parallelogram, it's going to have all 5 properties of a parallelogram. So the first thing I'm going to write down is it has all 5 properties of a parallelogram. And that means before you can say it's a rectangle, you first have to prove it's a parallelogram. So that's why on that question on the test, you'll prove it's a parallelogram, and then you'll either rule in or rule out the rectangle. Besides the fact that it's a parallelogram, it also has its definition. And what does its definition tell us? It has 4 right angles. So that's its next property. So it's a parallelogram. It's going to have 5 properties of the parallelogram. It's also got 4 right angles, so it's up to 6 properties already. But the lucky thing is the first 5 are the same as the parallelogram, which you already have in your mind. Okay? The next properties for your rectangle are If it's a rectangle, we already said this, then it's a parallelogram. We added that into the definition. So the next one that it has is its diagonals will be congruent. So if it's a rectangle, it will have congruent diagonals. Now I want us to think about what that means. Congruent diagonals. So when you look at the picture, that means AC is congruent to BD, right? But we know because it's a parallelogram, what else happens with the diagonals? They bisect each other, right? In a parallelogram, diagonals bisect each other. So not only is AC the same length as BD, but because the diagonals bisect each other, all four pieces are going to be the same. Does that make sense? Okay. So that's important. That just kind of follows from it. All right, and those are your properties for your rectangle. It's going to have all five properties of the parallelogram, four right angles, and congruent diagonals. Okay? I'm going to jump ahead to the rhombus next, and we're going to come back and do the examples after we go through all the properties. So we can just stay on our property sheet, okay? So now let's go to the rhombus. Again, I'm going to change the definition. A rhombus is a quadrilateral, but more specifically, it is a parallelogram. Yes, it is a rhombus. A rhombus is a rhombus, but it is more specifically a parallelogram, okay? And its definition is going to say that it has four congruent sides. So when we list our properties for a rhombus, the first one we're going to start with is it has all five properties. All five properties. Why does that not look right? That's right. I don't know. Of a parallelogram. So if it's a rhombus, it's going to have opposite sides parallel, opposite sides congruent, diagonals that bisect each other, consecutive angles that are supplementary, and whatever I left off. Opposite angles congruent, maybe. Maybe I didn't say that. So it's going to have all five properties of the parallelogram, and then the definition of the rhombus tells us it's going to have four congruent sides. And then the rhombus is going to have some more properties. The first one you're going to see here on your property sheet in the notes, though, is where it says it's a parallelogram, which we already took care of in the definition. So it has two more properties. It's going to have diagonals that are perpendicular, not congruent, but perpendicular. So you're going to have to keep straight which one has congruent diagonals and which one has perpendicular diagonals. To me, it's easy when you think about the picture. If I draw a picture of a rectangle, it looks obvious that the diagonals would have the same length. But if I look at a rhombus, which is slanted, it's a little more obvious that this diagonal will be longer than this diagonal, right? So to me, if you'll draw yourself a picture, if you get confused on the test, it'll help. This one has congruent diagonals, the rectangle. The rhombus is going to have perpendicular diagonals, which means they're going to form right angles where they intersect. Okay? And then the last thing that's true for the rhombus is that the diagonals will bisect opposite angles. Diagonals will bisect opposite angles. It says a pair, but it bisects both pairs of opposite angles. So it bisects the opposite angles. Number 4, bless you, the diagonals will bisect opposite angles. So I want us to think again in the picture about what that's going to mean. If it's a rhombus, what do we already know because it's a parallelogram about the opposite angles? They're congruent. So then that diagonal is going to come in and bisect those opposite angles, which means it's going to split each of these into 2 congruent angles, but that's going to make all 4 of them congruent. Agreed? Okay. And then the same if you think about the, oops, the same if you think about the other pair. These are going to be congruent to each other, right? So then be really careful. This is important. We already know it's a rhombus, right? So all four sides are congruent. So do you see that there are a lot of congruent triangles now in that picture? Okay, we've got a lot of angle, side angle, angle, side angle. We're going to have all of those triangles are going to be congruent to each other. So that's important when you start trying to figure out angle measures. Okay? All right. Properties for the rhombus, properties for the rectangle, and now the last one we're going to skip ahead is the square. Again, I'm going to skip all these little examples. Jump to the square. Square to me is the easiest one. Again, I'm going to change the definition. It is a quadrilateral, but more specifically, it is a parallelogram. That's right. So on your sheet, last one for today. Square. The square is a parallelogram, so the first property we're going to write down is that it has all 5 properties of a parallelogram. Yes, my son tells me in his math class that he just frantically writes the whole time and to just keep up with as the professor's writing across the board because there's no handed note, so it's just you frantically write. Yeah, in his class he has right now. All right, so all 5 properties of a parallelogram, then its definition tells us that it has what? Okay, and if it has 4 congruent sides, what does that mean?
It's a rhombus and a rectangle.
Okay, so notice it says 4 right angles first, which makes it a rectangle, and then it says 4 congruent sides, which makes it a rhombus. So what I'm going to write then for the definition is that it is both a it is both a rectangle and a rhombus, which means it's going to have all of their properties. Okay? So it's going to have all 5 properties of the parallelogram plus 2 more properties. So I'm just going to put plus 2 here for the rectangle. And then that's right. And then the rhombus has 3 additional properties. Yes. So the square ends up with 10 total properties. 5 from the parallelogram, 2 from the rectangle, 3 from the rhombus. And each of those had the 5 from the parallelogram. The great thing is it sounds like a lot, but when you look at it, it's really only 5 extra properties to memorize. 2 for the rectangle, 3 for the rhombus, the square has them all. Okay? All right. Only 5 more than what you already had to know. Okay, go back to the beginning where we skipped our first example. And let's see how many of these we can get through. Hopefully all of them. Okay, so this is the first one I think we skipped right here, correct? Okay. So woodworker constructs a rectangular picture frame. Always look to see what are they telling me I know. It's a rectangle. So JK is equal to 50 centimeters and JL is equal to 86 centimeters. Find HM. So you may want to label your picture. JK is 50 centimeters. JL, which is this diagonal, is 86 centimeters. We are looking for what? HM. So this little piece right here. Say it again. Okay, and what property, Tyler, are they using to get that? So we know it's a rectangle, therefore we know that it has congruent diagonals, which means that the other diagonal is also 86. So if this whole thing is 86 and we just want part of it, then we can just divide it by 2. So 86 divided by 2 is 43, and don't forget your units, centimeters. And like I told you, the math, it's not super hard, right? It's just knowing all the properties to know what do I now know about my shape. And I think the properties aren't that bad if you'll draw pictures because then it kind of stands out a little bit more if you can draw them kind of accurately. All right, next one we skipped. It says TVWX is a rhombus, find TV. So we're looking for TV, which is this side over here. What do we know since it's a rhombus that will help us with this? Say it again, Sarah. You do know something's 90 degrees. What do you know is 90 degrees? So we do know the diagonals are perpendicular, which will make all four of these 90 degrees, which does mean that 14a plus 20 is going to equal 90. But that's not going to help us find TV. That's going to help us in a minute find something else. What will help us find TV? Okay, we know that it's a rhombus, so not only are the opposite sides going to be congruent because it's a parallelogram, they're all four congruent, right? Because it's a rhombus. So if we can set these equal, we can find B, and then we can plug it in, and all four of the sides are the same, so that'll tell us TV. Does that make sense? Okay, so 3B plus 4 will equal 13B minus 9. What do you want to do? Add 9. Okay, add 9. So we have 3B plus 13 equals 13B. And then you said subtract 3B so that we have 13 equals 10B. And what do we do next? Divide by 10. So B is equal to 1.3. The question, though, is what is TV? So we go back to the picture and remind ourselves that all four sides are congruent. So TV is going to equal the same as any of the other sides. So we could use the 3B plus 4. That's easier. And plug in 1.3 for B. Good. So we get 3.9 plus 4, and you're correct. That is 7.9. Do they give us any units? No, so it's just 7.9. Okay. Go to the next one. Now we're back to what Sarah was talking about because it's the same picture, correct? And this time they want us to find angle VTZ. So let's first figure out what angle they're talking about. VTZ is this angle right here, right? They don't tell me that angle, but what do I know because it's a rhombus? Not that angle. So I'm going to come back to the one Sarah told us about, but first of all, I don't know this angle at all. Like there's no expression on it or anything. So what do I know? Edwin? Okay, so Sarah told us 14a plus 20 was pointing to this angle and that the diagonals are perpendicular in a rhombus. So that meant 14a plus 20 had to equal 90, right? Okay, but that only helps us find A. So then we have to go back and we say, okay, this angle up here, which is not the one we're looking for, is 5a minus 5. The one we're looking for is next to it, but what property of a rhombus helped us figure that out? Okay, diagonals bisect opposite angles. So because of that, this angle we are looking for will be the same measure as 5a minus 5, right? Okay, so we need to go through and find A and then plug it in to find the angle we're looking for. So subtract 20, 14a equals 70. Good, divide by 14, and Ridley said it is 5. So now if A equals 5, we're going to go back to find this angle. We decided it's the same as XTZ, which is 5A minus 5. So 5 times 5 minus 5. It's 20 what? Degrees. Don't forget your degree symbol, and don't forget your little m for your measure of your angle. Again, I don't think these are hard, but the hard part sometimes is problems like this where it's multi-step and you have to think about what property helps me get to eventually my goal, but not really my goal to start with. And so it can build and become a little more complicated. Okay. So the next one that we skipped was here, right? Or actually, we didn't ever even get to this. So this is, again, not how it's going to be stated on the test. On the test, I would give you this picture and say, what kind of quadrilateral is it? And you will have to rule in or rule out what it is. But on your homework for tonight, you're going to do what the directions say. So we're going to follow these directions. It says, show that the diagonals of the square are congruent, perpendicular bisectors. That's loaded. So let's break it apart. If we want to show the diagonals are first congruent, what are we going to have to use? Okay, we'll have to draw the diagonals, but what are we going to have to use in terms of how can we prove our diagonals are congruent? Distance. We need to use our distance formula to show congruence. Just like we talked about on the board over there. When we said prove congruent, you guys said distance formula. Okay, if we want to show that they're perpendicular to each other, what are we going to have to use? Very good. We're going to have to do slope. And if they're perpendicular, they should have what kind of slope? Nope, that's parallel. Opposite reciprocal. So we're going to check to see, do they have the opposite reciprocal slope? And then to show that they are bisecting each other, how did we say we could prove that they bisect each other? Same midpoint. So this is going to take a little bit, right? Because we're going to have to show 3 things about those diagonals. So let's get started. Number 1, we're going to show that the diagonals are congruent. So let's start with distance of what is it, H? FH. I'm going to go pretty quick. You guys work with me. So we're using the coordinates F and H. What are we going to have in here? -1 minus 0 squared plus, and 3 minus a negative becomes 3 plus 4, right? Squared. So we have the square root of -1 squared plus 7 squared, which is 1 plus 49, which is the square root of 50, which reduces to 5 square roots of 2. 25 times 2, the square root of 25 is 5. Okay, so I'll show that there. Square root of 25 times the square root of 2. Okay, now we're going to do, we did FH, so now we want to do what? EG, because we're trying to show that the diagonals are congruent. So we do E to G. Say it again, I'm sorry. Where are you getting plus 1? Okay, be careful. So -4 minus 3 squared plus, it would, very good, -1 minus 0. Not that that really makes a difference, but the formula is minus. So then that gives us the square root of -7 squared plus -1 squared, which is the square root of 49 plus 1. Square root of 50, which we already know is 5 square roots of 2. Don't forget to state what that tells you about those 2 lines then. What do we now know? They're congruent. So you would say FH is congruent to EG. That's the first thing they said to show. Show they're congruent, perpendicular bisectors. So we did the first thing. Now let's go on to the second thing. To show they're perpendicular, what are we looking for? Okay, slopes. So we want to find the slope of FH. And again, since it's already graphed, we can just count. What's our slope from F to H? Okay, so -7. -7 over 1, or just -7. What's the slope of EG? Okay, so we're going up 1, right 7, so that would be a positive 1/7. And are those opposite reciprocals of each other? So then this information tells us FH is perpendicular to EG. So we've got that they are congruent, we've now got that they're perpendicular, and the last thing we have to show is that they are bisectors of each other. Sorry, that should say EG. So then the last step will be to find what? Midpoint. Remember, the quickest way to show they bisect each other is to just show they have the same midpoint. Because in order to intersect and split each other into two congruent parts, they have to be crossing at the same midpoint. So number 3 will be to find the midpoint hate it. It's because I messed up when I clicked something a while ago. But anyway, midpoint of FH. We'll use our midpoint formula. Midpoint formula, remember, we add the x's and divide by 2, add the y's and divide by 2. So what will we be adding here? -1 plus 0 divided by 2, comma. Plus a -4 would just be -4 over 2. That gives us a midpoint of -1/2, comma, -1/2. Okay. And then we'll do the same thing for the last one. So midpoint of, for some reason if I write in cursive it doesn't erase it. So midpoint of, and then we're doing EG. All right, so midpoint from E to G, we're going to have -4 plus 3 divided by 2. -1 plus 0 divided by 2. And that does simplify to -1/2 and -1/2, right? And so then we could say, because of that, FH and EG bisect each other, right? So FH and EG bisect each other. Oh my goodness, come on. It's long. Okay, do we have one problem left? Yeah. Proof? Okay, let's see if we can get through our proof. No, we didn't need it for that. Sorry, I had given you a graph already on your paper. Okay. So this one wants us to prove RQ is congruent to RS. We want to get RQ congruent to RS. That's our goal. All right, and we know that the little shape, PQTS, is a rhombus, and that it has a diagonal that we're going to say is continuous through PR. So even though PT is technically the diagonal of this, they're just telling you it is one continuous line that does go all the way to R. Okay, so think back when we started trying to prove pieces congruent. What did we do before we proved little pieces congruent? We proved the triangles congruent. And then what did we use once the triangles were congruent? CPCTC. So let's see if knowing this is a rhombus would lead us to proving two triangles congruent, which could then lead us to the parts congruent. So if it's a rhombus, we know for sure all 4 sides are going to be congruent, right? Okay. What else do we know if it's a rhombus? Molly? Okay, we only have one diagonal in the picture, though. But we only have one diagonal in the picture. Okay, the diagonals bisects the opposite angles. So that means if I'm looking at angle QPS, would we agree that this PR is going to bisect that angle? And then the same thing here, QTS would be bisected, correct? Okay. And if we're thinking about triangles here, remember we're going to want to talk about a triangle that includes QR, right? So we have to be talking about this triangle either here that goes up or that goes all the way back to here, because we have to include QR. And then the same here, we have to be talking either about RS back to T or RS back to P. We want to try to prove those two triangles congruent so their parts are congruent. And we would already have this side's congruent to this side, right? And we would have this angle's congruent to this angle. And PR would be congruent to itself by reflexive. And so then is the top triangle congruent to the bottom triangle? Side, angle, side. And if that's true, then we have CPCTC, right? Okay, let's put it down. So you've got your statements and reasons. I'm going to abbreviate S and R just for my notes. Don't do that on your homework. Yes, so all of this would go in as our statement number 1. And the reason would be given. And then what did we say next? Okay, so we could say angle. How are we going to name those angles? Q, P, T. Actually, it wouldn't be T because we're talking about the big triangle, so it needs to be R, right? I mean, it is QPT, but since we're talking big triangle, it's really QPR. Is congruent to angle SPR, good. And that's because of why? Okay, so in a rhombus, diagonals bisect opposite angles. Now we could have said the other angles were congruent at the same time, but did we decide we need those other angles? No. So since we chose to go about it the way we were, we could say these angles and then use angle, side. No, that's not in our big triangle, is it? Never mind. We couldn't do that. Okay. But the R is not a part of this rhombus. This is the rhombus. So we couldn't do that. So we don't need those green angles. Do we all agree we don't need those? Okay. So then what was the next thing that we stated and marked? We did reflexive property. PR is congruent to PR. It doesn't change because it's leaning right on top of itself. And that was reflexive property of congruence. Okay, and then what else did we mark? PQ was congruent to PS. Be careful, that was not ever listed in our proof. It was marked already on the picture, but we never put it in our proof. Where does PQ being congruent to PS come from? Definition of a rhombus. Good. So definition of a rhombus. And then now we have which two triangles congruent? Triangle QPR is congruent to triangle SPR. And that was by what again? SAS, side, angle, side. And then now we can state what we wanted to prove. RQ is congruent to RS. And that was by C, P, C, T, C. And remember we said P comes before T in the alphabet and every other letter is a C.